Okay, here is my video guide for 5 of the problems, 1, 3, 4, 6, and 7 on our Chapter 5 individual test review. And we're going to start with taking a look at number 1. Alright, and so on number 1 it says use any tool to solve for the missing sides and show all of our work. There's different ways that you could go about solving this. Different tools that you could use. If you wanted to, you could find or use inverse trigonometry to find one of the missing angles, and then use regular trigonometry to solve for the missing side. But what I'm going to do here is I see a right triangle with one missing side, and so I'm going to use the Pythagorean theorem on both of them. And so looking at that, the Pythagorean theorem again is a squared plus b squared equals c squared, where a and b are your legs and c is your hypotenuse. And so even I'm going to label that on my triangle. We can call 7a, it's one of my legs. We can call 2b, and then we can call the hypotenuse here c. And again, I always know the hypotenuse because it's that side that's across from the 90. So let's plug in and let's solve. Plugging in for a squared, that would be 7 squared. Plugging in for b squared, that would be 2 squared. And then c squared is still c squared because that's what we're looking for. You can use a calculator here, or maybe you can do the squaring in your head, but 7 squared would give you 49, 2 squared would give you 4, and c squared again is still c squared. Only a couple more steps to go now. Let's add these two together. 49 plus 4, that's 53, equals c squared. Now to get c just to be c instead of c squared, we need to square root both sides, and so what you end up getting here is c equals, and the way I'm going to write it is with the square root of 53. So that would be your answer. C equals the square roots, that missing side. Here c is the square root of 53. If you want to write that as a decimal, the decimal for that one would be, if I can open my calculator here, the square root of 53 would be 7.28. So if you wanted to, you could say also equals 7.28. The same thing would go for part B here. Okay, again, I would use Pythagorean theorem because I see a right triangle with two sides and a missing hypotenuse. I could label the 5.2a, the 9.2b, and then the hypotenuse c. Again, I know it's the hypotenuse, it's across from the 90. And I would use the equation a squared plus b squared equals c squared. Now, I'm going to let you try to do this one, try to follow the same thing I did here, and see what you end up getting. Looking at the next one, I believe I said I was going to do 1, 3, 4, 6, and 7, and so let's look at 3. And on 3 here, we are doing our special right triangles, and the first one is going to be a 30, 60, 90. And then the second one is going to be a 45, 45, 90. So I'm going to use those rules here to solve. And remember, this is the way I explain the rules, is that across from your 30, which your 30-degree angle would be right here, across from your 30 is your short leg. And for a 30, 60, 90, what you can do is short leg times 2 to find your hypotenuse. And you can do short leg times 3, times the square root of 3, excuse me, to find the long leg. And so you can think of it like this and say, okay, what value times the square root of 3 would get you 5 times the square root of 3, and what value, and then you could use that to figure out a. But what else happens in 30, 60, 90s is you can also go backwards. Okay, so if it's short leg times the square root of 3 to get to the long leg, well, you can go backwards, and you could just divide by the square root of 3 to find the short leg. Same would go for here. I don't want to write it in here, it would get too messy. But by using these rules, I see that b would have to equal 5. And just following the rules, 5 times the square root of 3 would get you 5 square root of 3, or working backwards, 5 times the square root of 3 divided by the square root of 3 would just give you 5. Now following my other rule, the short leg times 2 giving you hypotenuse, that would give you a equaling 10. And that would be your two answers there. B equaling 5, A equaling 10, and you really don't have to show much more work than that because we're just using the 30, 60, 90 rule. For the 45, 45, 90 rule, what we do, the legs are exactly the same, and so this angle is also 45, which tells me A and B are going to be the same number because they're both legs. And then in terms of writing it like I did in A, what you could think of is you could do the leg times 1 would give you the other leg, or the leg times the square root of 2 will give you the hypotenuse. So again, I'm thinking what number times the square root of 2 will give you 9 square root of 2. And if you can't think of the number, again, same as we did here, it also works backwards. So I could go from the hypotenuse to the leg by doing the division of the square root of 2. And again, what that would give you as an answer would be that B equals 9, and that follows the rule. 9 times the square root of 2 gives you 9 square root of 2. Or if I work backwards, 9 times the square root of 2 divided by the square root of 2 would just give me 9. And then A is the same because the leg times 1 gives you A, and so A would also equal 9 there. All right, so that's 1, 3, on to 4. We have the Pythagorean triples. All right, and the two Pythagorean triples we know from class are 3, 4, and 5, which means the leg is 3, the other leg is 4. That would mean the hypotenuse would be 5. And the other Pythagorean triple was 5, 12, 13, meaning one of the legs was 5, the other leg was 12, and then the hypotenuse was 13. Now, what goes with these are all an infinite amount of variations. I could multiply all of these by 2, and a variation of the 3, 4, 5 could be 6, 8, 10. Another variation of the 3, 4, 5 could be 9, 12, 15. And I could just keep multiplying this original one by different values. You can see here I multiplied them all by 2. In the bottom one I multiplied them all by 3. I could do that for infinitely amount of values there. And we'll take a couple variations of this one as well. One could be 10, 24, and 26. Another could be 15, 36, 39. And again, I could have infinite amount of variations. And the reason I'm writing those is because I'm going to look for a variation to one of these original ones so that I can use it to solve this problem. And what I notice, and it takes a little bit to get better at noticing this pattern, but what I notice is 50 is 5 times 10. I notice that 130 is 13 times 10, which leads me to believe that this is going to be a 5, 12, 13 Pythagorean triple. Because I see a 5 here, I see a 13 here, they're getting multiplied by the same thing, which is 10. So I have the 5 as one of my legs, the 13 is my hypotenuse, which leads me to make the conclusion that my missing side here would be 12 times 10, because it's this missing part, 12. And I want to multiply it by the same thing, everything else got multiplied, and like that gets me to the conclusion that the question mark here equals 120. So it was just, the key to here is just getting better at finding the pattern. If you are uncomfortable finding the pattern, you can always use the Pythagorean theorem, a squared plus b squared equals c squared, and you could have came up with 120 that way. But this can be quicker if you can notice that this was 5 times 10, this is 13 times 10, so the last one must be 12 times 10. Okay, moving on to 6. 6 is a word problem that our best bet is to draw it out. And so we see that we have a post supported by 2 wires, these wires one on each side and going in opposite direction. The 2 wires create an 80-degree angle, and when the wires are connected to the ground, they are 12 meters apart. And additionally, that one of the wires is going to form a 40-degree angle with the ground. So let's draw this out. We have the post here. We have these wires that I'm going to put in red coming off of it. And so one wire goes one direction this way, and the other wire goes the other direction this way. Let's put the ground in here. We'll make it green like it's grass or something. And I know that from this point to this point is 12 meters. So the base kind of the ground here is 12 meters. I know that the angle between the 2 wires, this angle right here, that is 80 degrees. So the angle between the 2 wires is 80 degrees. And I know that one of the wires forms a 40-degree angle with the ground, and because it's a word problem that we're drawing out, we get to choose, and I'm going to choose this to be my 40-degree angle. And the triangle sum theorem then tells me that this angle over here would be 60, which will come into play during this problem at some point. So now I have my triangle. I'm looking for the length of the wires, and that's plural. I'm looking for the length of both wires, and so I'm looking for this length here, which I'm going to call, if I can get my text box to work, I'm going to call this length here, whatever, I'll use my drawing, x, and I'm going to call this length over here y. Now the best way to do this, some people like to see it as two right triangles, but if we see it as two right triangles, we actually can't do it. We need to see this as a non-right triangle, and we're going to end up using the law of sines, because I have 80 and the side across from it, and I have 40 and the x across from that. So setting up the law of sines, that is going to be the sine of 80 divided by the side across from it, which is 12, equals the sine of 40 divided by the side across from it, which is x. Now cross multiplying here, I get x times the sine of 80, which is x times the sine of 80, equals the other cross multiplication, which is 12 times the sine of 40. I need to divide both sides by the sine of 80 so that I get x by itself, and so that'll look like x equals 12 times the sine of 40 divided by the sine of 80. And then I can plug that into my calculator and get a value for x. Same kind of thing is going to go for solving for y. I'm going to set it up again as a law of sines problem, and I'm going to again use the sine of 80 over 12 because that stays consistent. But instead of using the sine of 40 and x, I'm going to use the sine of 60 and y. And so setting it up, again, it's going to look like the sine of 80 over 12. I'm going to keep that consistent, but I'm changing this one to the sine of 60 over y. And again, I would do the same thing, cross multiply, get y by itself, and end up getting a number for y, and then I would have my answer because I'm just looking for the answer for x and for y. All right, lastly here, we have Bert, Ernie, and Elmo going camping, and the way I do this problem is, again, just draw it out. So I'm going to say that Bert is down here, Ernie is over here, and Elmo is up top. And again, you could draw this out differently. This is just the way that I'm seeing it. All right. And then I'm going to create this triangle between Bert, Ernie, and Elmo. So I'm going to use from here to Bert, and then from Bert to Ernie, and then we'll complete the triangle here. Now it's not perfect. It's not even going to be the most accurate drawing, but that's okay. As long as I have my triangle in place, I can start evaluating. I noticed that Bert and Ernie are 10 meters apart, so this length down here is 10 meters. I know that the angle formed at Bert is 30 degrees. And I know the angle formed at Elmo is 105 degrees. And then from there, I need to figure out how far apart are Ernie and Elmo, and so I'm looking for x. I'll call it x, this distance between Elmo and Ernie. Again, it's a non-right triangle, two angles, a length across from the angle and an x across from the other angle. This is going to be a law of sines problem. Anytime it is a non-right triangle and you have two angles, generally it's going to be law of sines. And so we're going to set that up. And what it's going to be is the sine of 105 divided by the side across from the 105, which is 10, equals the other angle, the sine of the other angle, which is the sine of 30, divided by the side across from it, which is x. And it's much like the problem right here again. We're going to cross multiply. Cross multiplying would give you x times the sine of 105 equals the other cross multiplication, 10 times the sine of 30. Dividing both sides by the sine of 105 so that x gets by itself, you're left with, if I can put my thing, x equals 10 times the sine of 30 divided by the sine of 105, which you can plug into the calculator and get an answer for x. That's everything. That's 1, 3, 4, 6, and 7. And I'm just at my time limit now. So if you have further questions, make sure you reach out and ask. And I'm more than happy to explain these maybe a little slower without the time constraint, or maybe break it up into individual videos.